outer worlds don't really have a solid surface, and so you might ask, well, how can we have any volcanoes out here? Well, in fact, what we've got to remember is that each of these is attended by a large collection of moons. Saturn, I think, now has some 79 moons, so there are rather more objects out there than just the 4 gas giants. Here's a picture of the moon Io, the innermost of the large moons of Jupiter, crossing across in front of the face of the giant planet. If we look closely at Io, this is a picture that one of the Voyager spacecraft took. Then what we see is this amazing coloured landscape, and it looks like a pizza, doesn't it? But the 4 colours that you see on the surface here are in fact black, white, yellow and an orangey red colour, and there are only those 4 colours. And if you remember doing chemistry at school, then you might remember taking sulfur and heating it up and then pouring it out onto the bench, or pouring it into water, or letting it cool more slowly. And depending on how fast or slower it cools, you get 4 different forms of sulfur, 4 different allotropes they're called, and they are white, black, yellow and orange, the most familiar being the yellow, of course, but the others are just different forms of it where the molecules group together differently, and it's all pure sulfur. So everything that you see on the surface of Io there is sulfur. But looking back at Io, Voyager caught a volcano in action. Here it is throwing material up, backlit by the light from the sun, so that the material can be seen being ejected upwards out into space and scattering all over the surface of the little moon Io. And it turns out that every one of those black dots is the caldera of one of these sulfur volcanoes on Io. We can see it down into a couple of them here, look. You can see the top one out there with its very red and orange colours, and lots of very runny sulphur that's flowed out of it, and then down into an active one where there's much more of the high temperature black sulphur formed around what looks like a crater lake. So these are sulphur volcanoes rather than molten rock volcanoes, showing something about the composition and the chemistry that's making up the little moon Io. There's another shot of a giant volcano called Pele, which is named after a Hawaiian god rather than the footballer, and that's erupting out into space again. You can see the material up above the edge of Io there being ejected away out into space. And I think we've even got a little movie of it. I hope that's coming through okay. I'll just leave that running for a moment, but there is Pele erupting material, and it's blowing downwind and spraying all over the surface, and you can see how that would very quickly coat the surface of Io in new material all the time. And of course it's that recoating that means that we don't see any impact craters. They're all filled in by the ejecta from the very, very active volcanoes. In fact, if you look really closely at this, down at about the, where is it, about the 7 o'clock position, there is another active volcano that's been caught just throwing some material off out into space there along the limb. And if you look along the terminator, there's another one that you can see moving, the moving cloud at about the 10 o'clock position on the terminator between the day and night side. There's another volcano going off. So there are at least 3 active volcanoes caught in this image, possibly more. And Io is the most volcanic place that we know about. Now, if we move outwards to the second moon of Jupiter called Europa, I just love this photograph. What this shows is the ice shiny white covering coating most of the surface with these weird cracks and grooves and patches of brown material that's overlaying on top of the ice there, and really the question at the bottom of the screen there, just what is that brown stuff, is quite intriguing. What we think is going on is that there is a thick ice covering, maybe tens of kilometers thick, overlaying a warm salty ocean. And the warm salty ocean's been detected by the magnetometers on various spacecraft. They can tell as a electrically conducting fluid beneath. And also we think that some of that fluid is working its way up through the cracks and producing ice and water volcanoes. Obviously the water turns to ice crystals the moment it hits the near vacuum that surrounds Europa, and so they shower ice onto the surface, but it's bringing with it that brown stuff, which has got to be some sort of organic chemical, and looks just like the same color as the scum on our village pond. And it wouldn't surprise me at all if we don't eventually sample it and discover that it is the product of some sort of life that's living in that briny ocean. We've even got photographs of that process in action now. There's one there at the bottom left taken by a spacecraft doing a flyby over the surface of Europa and catching water plumes being ejected along those cracks. So we know that they're active now. And then we've got some Hubble Space Telescope photographs at the top right there, showing in really quite low resolution, but showing the bright white areas are where there are some eruptions that have been caught coming off the surface of the little moon. Now, estimates of the amount of water on Europa, quite incredible. It's got more water than the whole of the Earth's oceans. This diagram has kind of shown what would happen if you could gather together all of the water on the Earth out of the oceans and make a droplet of water sat there on top of the United States. Do the same for Europa, you get a slightly larger droplet, just a 50% or so larger amount of water. Quite an amazing statistic, really. So the curious thing is that both of these moons, Europa and Io, are about the same size as the Earth's moon, and they're probably about the same age. So the question is, why are they not dead and frozen? Why is Io so volcanically active? And what's keeping those inner layers of Europa warm enough for there to be liquid water underneath the ice? It has to do with gravity. It's the combined effect of a tug of war between the three moons of Jupiter that are shown here orbiting around the planet, not including the outermost one, Callisto. Callisto seems to be off sulking, doing its own thing and not playing the game. But the others are in an exact 4:2:1 orbital ratio. So every 4 laps that Io does, Ganymede does 1 and Europa does exactly 2. You'll see Ganymede catch Europa at the top. Then when it gets to the top again, there's no one at home. The second time round, it catches Europa. And if you follow Europa, you'll see that does the same thing with Ganymede. It'll catch Ganymede at the bottom this time around. There it goes. And it goes around again. And by the time it gets to the bottom, there's no one at home. And on the second lap for Europa, it catches up with Ganymede again. That creates a tug of war. It puts the moons into quite elliptical orbits, which means that the distance from Jupiter varies from a fairly close approach to a more distant approach as each of the moons goes around on its orbit. But gravity decreases with the distance, and so what happens is that the near side of any given moon is pulled more strongly than the far side of that same moon. So it stretches them into a slightly elliptical shape. And that shape is made more elliptical when they close in on Jupiter at the near point of their orbit, and it relaxes back again as it goes to the far point in its orbit, as it's further away from Jupiter, and the effect of gravity diminishes. So they're constantly being stretched and squished. And like a squash ball, at the end of a game of squash, they get quite hot in the center from the pummeling. the same is happening to Io. It's being heated enormously by all the friction of being stretched and squished and turned into almost completely molten. And that's why it's so violently volcanic. The effect's a bit less for Europa, a little bit further away. The power of Jupiter's gravity is not so significant, but it's enough to keep that liquid water warm underneath the ice. And indeed, Ganymede also gets a certain amount of warming and probably also has an ice layer beneath it. We're not quite so sure about that. We have the magnetometer data that says that it's true, but we've not caught any of that water erupting. Although it does look from pictures of the surface like it's a young and uncratered surface, so something's happening there. Now Callisto's in a different orbit. It's not synchronized with the other three, and when you look at it, it's an old dead world, exactly as you would have expected for a modest size object round about the same size as the planet Mercury. And that's so the tidal heating is not occurring on Callisto. It's minding its own business and has cooled down over its lifetime, just as we would have expected. But the other three are definitely quite a surprise. So if we leave Jupiter and we go out to the planet Saturn, again, we're not going to look at Saturn, we're not going to look at its marvelous rings, but what we are going to do is look at some of the worlds that are Saturn's moons. And in particular, there's a couple of photographs of the largest moon, Titan, again, about the same size as the planet Mercury. These guys would be called planets if they orbited around the sun, but they don't, they orbit their host planet, so we call them moons. So the left-hand photograph is looking down with an infrared camera from the Cassini spacecraft, and can just about see the clouds in the Titan atmosphere there, and possibly through it to some of the ground beneath. It's the use of infrared that allows us to see through what is otherwise quite a hazy atmosphere. And so when you look at it with a telescope from the Earth, all you see is that haze layer. We talked in the other lecture about the atmospheres of some of the inner planets, and Titan has an atmosphere that's about 1.5 times as dense as our own atmosphere here on Earth. So it's really quite Earth-like, and of course actually it looks rather like the Earth in that photograph. The image on the right though is a volcano on Titan, and this was imaged with radar, and it's an ice volcano. The surface of Titan is mostly made of frozen water ice, and a lot of the material making up the body of the planet is probably ice. I say planet, world. And so we have ice volcanoes. Again, the temperature here is minus 160 degrees centigrade, so it's very cold, and that ice is taking the place of rock. It's quite rigid at those low temperatures. But the Huygens space probe was parachuted down through Titan's atmosphere. There's just a couple of photographs from it. The big one on the left is a bit of a fisheye view, and we have a couple of mountain ranges with fairly spiky looking mountains to the left and just to the right of center. And then we have a couple of valleys between them. And in that main valley, roughly in the middle of the photograph there, we can see what look like rivers, the classic sort of tree-like branching structures of rivers running across what looks like a snowy valley. And then we can see other river-like structures further down the photograph on the darker material. Now the probe came down on its parachute, and when it landed, it took the picture on the right there, and it landed on what looks like a dried up lake bed, or perhaps a pebble-covered riverbank. We're not quite sure. It only had batteries for about 30 minutes and wasn't able to move to go off and explore. So probably be a nice idea if we could send a space probe out to Titan with some sort of rover and explore a bit more. But the orbiter did some good work as well. It took some radar pictures down through the atmosphere, and this is the Kraken Mare, a lake on Titan. and the lake is not full of water. The water's all frozen up hard as rock, and what we have here is liquid methane, CH4, the natural gas that we use for cooking and heating, flowing as water, as a liquid, down the river channels that you can see there. There's lots of rivers all leading into this lake. And then in the little inset area there, we've got down the left-hand strip photographs taken over a number of years. The first one in 2007 there, and then it's changed quite dramatically in 2013, 2014 and 2015. Now that's not the land changing, that is the water level changing. Now we're running out of time, it's just come up to say. I thought it had given us an extension, but we'll crack on. That's the level of the lake changing with the seasons. Another moon here is Enceladus. This was a real surprise. You can see the cracks and the grooves in an ice-covered surface again, very much like Europa at Jupiter, this one. A very small moon, only 500 kilometers across. And there is a picture of the whole of the surface. Some of it's got a few craters on and is therefore a little bit older and less resurfaced than the bit with the cracks, the blue cracks. They're called the tiger stripes. Why? Because tigers aren't blue, I don't know. But again, we've caught those tiger stripes emitting water out in huge plumes. So that's telling us that there is another icy ocean. And again, this could be a candidate for life because they've flown the probe through those plumes and sampled it, and it contains organic material and hydrogen. And those could be a fuel or a food for bacterial life, perhaps. So we're going to leave Saturn behind now, go to the outer two planets, and in fact we're going to skip over the planet Uranus and just look at the moon of Neptune called Triton, which has these amazing terrain taken by Voyager 2. We've got grooves, we've got cracks, we've got a wrinkly surface at the top that's called the cantaloupe terrain, named after the melon. We've got what looks like pink snow that turns out to be frozen nitrogen. The temperature here is minus 220 degrees. But those black bits, those black things are geysers. They're all pointing in the same direction. If you look at them, they're all pointing diagonally up and to the right. And they are geysers where liquid nitrogen is erupting from beneath the surface, carrying dirty material. And so this is a super cryovolcano. It's an eruption of what would be part of our atmosphere here on Earth, nitrogen, but that's taking the place of the fluid of the volcanoes. So that's an artist's impression on the left, but the right-hand two images do in fact just about show some plumes travelling downwind in the thin Tritonian atmosphere. And of course, we mustn't exclude Pluto. Planet or not, it's a dwarf planet according to the official naming convention now. And the New Horizons probe produced some amazing photographs here of a huge glacier flowing across the surface and only a few craters. So this is a young, active surface on an old planet. It must be geologically active and recycling itself. Here's an enhanced colour image of it, showing the different chemicals that make up the ices on the surface of Pluto. So we've got a mixture of nitrogen, methane, carbon monoxide and water, all covering the surface of Pluto. And some of the ice flows look incredibly like the ice flows of the Arctic here. So we're definitely seeing that glacier moving across the surface and rubbing out the impact craters as it goes. And yes, we've detected volcanoes, ice volcanoes, emitting material out and into the thin Plutonian atmosphere. So it's an active little world. And the question is why? It is accompanied by its large moon Charon, which also shows quite a young surface, but the two are in complete lock. They both keep the same face pointing towards each other. And so we don't quite understand what the source of that energy that's keeping their interiors warm is all about. still a bit of a mystery. Here is just a zoom in on some of the surface features on the moon Charon. And because we're running out of time, I will zip back to the Earth and end with one more slide here, which is deep in those trenches down on the mid-Atlantic ridge that we talked about in part 1. We find these black smokers where superheated mineral-rich water is coming out from underneath the ground, bursting into the cold water and dumping all of its minerals and nutrients. And living, those pink and white things, those are tube worms. They live and feed along with colonies of bacteria and all sorts of strange creatures. And they live and feed entirely on the minerals and the energy released in the chemicals from the minerals coming out of the ground. They're not any part of the food chain of the surface living creatures that all depend on the sun, directly or indirectly, including humans, of course. And it's quite possible that these were the origin of life on Earth, was at these black smokers. It evolved here first and then migrated up to the surface. And I would be prepared to take a bet that eventually we'll discover that some of these volcanic worlds that we see around the solar system, particularly things like Ceres and Europa and Ganymede and Enceladus and some of the other ice-rich and water ocean containing worlds, will have these black smokers down there underneath in the protected environments beneath their icy shells. And I'd be prepared to take another small bet that there will be life having evolved around them, because it's got all the conditions necessary, and I really don't see why that would not happen. But of course, as Sir Patrick always used to say, we just don't know, so we need to go and find out.